Hello viewers, my name is Eric and today we will be looking at how to take off from the ground using a single engine on twin engine planes. Now to do this we need several things. First, although not required, but calm weather would be a good idea. Alternatively, because of the huge amounts of runway needed, you could either select a long runway or give yourself some massive headwinds, or both. Because for a asymmetric thrust to work, especially on the ground, you need control authority on the rudder and on the wheels. And when you only gain that control authority by having, firstly, of course, huge control surfaces, but secondly, also airspeed and air hitting it. So, for this demonstration, I've chosen Hong Kong International Airport, Victor Hotel, which has, I think, a 13 or 14,000 foot runway, and I've chosen the Twin Star, the Diamond Twin Star, because it has relatively low power engines, and yeah, in my tests, you pretty much have to use the entire runway to get this thing off the ground. Now, winds are 0 right now, so as you can see, my indicated is the same as my true airspeed, which is 0, and yeah. And the plane is set to gross weight, just because I know it's possible to take off on gross weight. Now, how much you want your plane to weigh during a single engine takeoff really depends on, because the heavier you weigh, the more thrust you need, and thus the more asymmetric thrust you need to counter. But at the same time, the heavier you weigh, the more weight is put on your front gear, allowing you to probably steer better. So it really comes down to math that I can't do. So anyway, we're gonna just fail the right engine, because that will give us the most dramatic yaw force, because the propellers spin clockwise. Both propellers spin clockwise, so when the left propeller spins clockwise, its air is hitting the rudder, causing, you to turn left. Add to that the propeller itself is the torque from the propeller is trying to make the plane roll left. So those two facts, and add to that, the propeller itself is located on the left side, so of course it's gonna be pushing left. So actually that would help. My bad. So that would actually be the optimal case, because then we would have at least some force countering our thrust on the left side. So let me just start displaying up. Not that I know how, but I'm gonna do this. Then I am going to come on, keys, work, damn it. Alright, cool. Now my right engine started, and let's rock and roll. Yep, the power is good. Brakes off, and we're just gonna do this from the outside view. So right now I'm gonna start, like, your initial push will always push you towards the other side. There's nothing you can do about it initially. But as you gain speed, see, you can put yourself right back on center line. Now, as you increase speed, your control authority of your control surfaces also increases. and that means you can put in more throttle. Right now I'm at 28% throttle, and my left engine's not feathered because the plane hasn't detected that it needs to feather it yet. But whatever, it doesn't matter. So as we increase speed, put in more power. And as you can see, we are using a bit of rudder, but it's not too much. Nothing we can't handle. Alright, faster. Now, the reason I chose this plane is because it's light, so its twin engine, takeoff speed is takeoff distance is probably like 2,000 feet or something, which isn't a lot. Yeah. It's twin engines. You basically have to this plane pretty much has the shortest, well, not the shortest, but one of the shortest takeoff distances of any, like compared to larger twins. And because the single engine takeoff requires such large massive runway, so you need to have the minimum takeoff distance, or you can set yourself ridiculous headwinds, but that is another a different deal, which we can try later, because I tried recording a video doing a single engine takeoff on a 350 and an Airbus 350, and it did not work out well. So I think for such a takeoff to work, you need to start with a 50 or 60 knot headwind. But that would be into airmet tango territory. No, sigmet territory, because when winds are above 50 knots. See, now we lift off, and we're airborne, and gear up, and let's just give ourselves a bit of stable flight. Roll right a bit, and use my rudder to maintain. Now, you're not going to be able to really climb on one engine. The one engine is basically designed to keep you airborne when the other fails. So it's a miracle that we managed to get airborne at all. Basically, now I can pitch up a bit and try to climb. And that is how you do a single engine takeoff in a Diamond DA42. Now, how you do a single engine landing in a twin engine, it's quite simple. You simply maintain this method of maintaining your maintaining your path. And of course, this is not because in IFR you have to follow the glide slope, but in VFR, or if you're a rebel, you can just, and because since this is not going to be realistic, you're not going to actually ever try to take off in a twin with only one engine, because that is just nuts. And as you can see, I used up the entire 13,000 foot runway. That's not something very realistic. I mean, that's not something any government is going to allow you to do. But yeah. So this is just hypothetical, just for fun. So in landing a single engine aircraft, well, the easiest way to do it is to put yourself on a real glide slope, the angle at which your plane is going to descend at. So when you're high enough, just simply pull back the throttle, and then your plane will pretty much, it's not going to be perfect, but it will drop and give you fairly little resistance. Now, as you can see, obviously my right engine has more drag because it isn't feathered, so it's actually like a disc, while my left engine, it is feathered. So when you pull the power idle, the feathered engine, because it isn't producing any, basically because it isn't angled for maximum RPM. In fact, it's angled for minimum RPM, so it also produces minimum drag. that is why propellers are feather. But anyway, that's how you do it in a Diamond Aircraft 42. And now, upcoming, is we're gonna try it with unrealistic headwinds, like maybe 80 knot headwinds, in a Airbus 350. I'll be right back.